This video is about the most important requirement of data-driven decision making, which is using clean data. I will use A/B testing as an example because it's one of the most common sources of dirty data. So if you run experiments or you rely on experiments for making decisions, this video is for you. This paper here exists because there was something fundamentally wrong about how we collect data from experiments to make data-driven decisions. And most people think that data-driven decisions fail because of bad analysis. In reality, they fail long before the analysis because we are collecting the wrong data. We think we are measuring something, but in reality, we're measuring something else. And you may think that this is odd or even impossible, but I'm going to show you that it's a lot more common than you think. So a bit of context. I've been running experiments for clients for the past 7 years. And during this time, I developed a split testing tool that my clients use for testing, which is now available for free. Here it is. So while building this tool, I ran into a recurring anomaly. This is something probably you have noticed as well. And this is the fact that despite running sound experiments that are statistically significant, you end up with winners that when you roll out on the site, after a few weeks, the uplift is completely gone. Now, this is normally labeled as reversion to the mean, but for me, there was something that didn't add up. So I started to dig deeper and I found the true source of the problem, which led to this white paper here. So let's name the problem. The problem is that when we run an experiment, we are trying to measure the steady state treatment effect, which is what happens on the long run if we deploy the winning variation. And this is in general what businesses want to measure, what businesses want to know. And this is also what professionals and agencies promise to measure. In reality, there is another fact, which is this one here, the novelty response effect. The novelty response effect applies only to returning visitors who have been exposed already in the past to the object you are testing on. So they have seen the control, and now when they come back to the site, they see a different version of it. Now this shock is what causes or not causes the conversion. So the effect you're measuring here is not is B better than A, but it is how shocking it is that B is different from A. You see? So this is a big difference in the question, and the data that come out of this exposure is different data. So we have on one side returning users that are affected by one type of experience, and new users that are affected by a different kind of experience. And just to be clear, this always happens. This is a structural issue. The extent to which it happens depends on the type of the business and on the time to conversion. Now I'm going to show you this graph, which should make it really easy to understand. This curve here is known as time to conversion density, and it is the number of conversions at any given time during the conversion window. Now, as you can see here, there is no unit because this process can unfold during hours, days, weeks, months, or even years, depending on the product being sold, on the conversion event that we have, and on the business. So some events are really quick. Time to conversion is really short. Think, for example, in newsletter sign up or even trial sign up in some cases. Some events require longer, for example, activation in SaaS or a purchase, okay? In some businesses, if you want to purchase a house, for example, it's gonna take months, if not years. So the width of this time to conversion is different. Now, why this is important? Because you can see here that as you start the experiment, nobody of the new people is converting. They start to convert later because they need time to process the information. They need time to make a decision. In the meantime, returning users, they are way farther along this curve. So some of them, they are close here to the peak, where is the moment of making a decision, and showing a different variation just nudges them to make the purchase. And you measure conversions on day one when you start the experiment, and you think that these are people converting and this is data that should go in your experiment, while in reality, the experience of these people has been conditioned from everything they've seen in the past, including the original version of that page. So these people should not be in your experiment. At this point, you should understand the difference between measuring persuasion for the new users and measuring reaction for the returning visitors. And if you think about the structure of the data we are collecting and distribution of the data we are collecting, in the early days, almost the entirety of conversions come from returning visitors who have seen something else. So we are measuring the reaction, not the steady state treatment effect. And this is why so many winning A/B tests don't stand the test of time. When you roll them up on the site, after a few weeks, you lose the uplift. That's just because you run out of returning visitors and the uplift you thought you measured was never there in the first place. So, if decisions depend on clean data, the first thing we must do is to collect data which are not contaminated. And this is why inside GTM Split, I have built the first exposure contamination protection. You have it here. So this toggle here, if it's checked, you will not enroll in the experiment users that may have seen the control version of the page in the past. If you uncheck it, the system will still tag the users with the first exposure contamination true or false, and will send this data to your analytics platform. So in any case, this solution allows you to either remove from the experiment entirely people who may have seen the control in the past, or tag them so that later when you analyze the data, you can separate people who were really new visitors who have never seen the control from the people who may have seen the control version in the past. And once you correct for first exposure contamination, the problem really disappears. That is, we start to make decisions with clean data and we start to actually measure what we think we were measuring all along. So, dirty data is everywhere. I hope this video helped you realize how deep this goes. If you want to read the full white paper, which I really recommend, you will find a link in the description below the video that will lead you to this page here, and then you can download the paper from here. Alright, I guess that's it for this video. I will see you at the next one. Ciao!